Let's look at the 5 basic clauses of the select statement. Select, from, where, order by, and limit. Select is really the only one that is required, but they do need to be used in this order as they are shown here for them to work properly. Let's look at what each one of them does. Here we see a query using all 5 of the clauses. Below the query, we see the result set, or the data that is returned when the query runs. Select describes the columns in the result set, or values that will be returned when queried. This is where you will list all the fields or columns that you want to show up in the result set. You separate each column with a comma. Here, we want first name and last name to show up. From tells what table you're getting the data from. This is always required if you're getting data from a database table. In this example, we want the data to come from the artist table. Where is where you can place criteria for what data you want from the table to filter the rows down to only those that match a condition that you state. Here, we only want names of artists from Italy. Order by will sort the rows in the order you specify, like alphabetizing or sorting biggest to smallest or smallest to biggest, etc. Our results will be alphabetized by last name, A to Z. Limit tells how many rows of the result set to show. Here we are limiting the result set to the first 2 rows that are returned. So we see our result set shows 2 artists, Leonardo da Vinci and Michelangelo. Their first and last names from the artist table. They both are from Italy, and they are sorted by last name alphabetically, and only 2 rows show up. Let's look more closely at the select clause. There are different ways to code columns with the select. You can reference all the columns of a table with an asterisk, or list column names like we saw in our example. You can also use calculated columns and functions as part of the select clause. When you use the asterisk, every column in the table will be returned. It is okay to use an asterisk this way, but once your project is developed and in production, you should probably avoid using it. You can also list each column separated with commas. Then only those columns listed will show up in the result set. You can show calculations in the select clause as well. Here we are using the date of death minus the date of birth to get the age of the artist at their death. Please note here that usually a date year would have a date data type, but these years are only numbers. Year data type values can't be before 1970, and since many of these artists were born or died before 1970, we're not using the year date data type here. So to subtract dates properly, you should use different date functions that we'll go over in a later lesson. Here also note the as keyword is followed with an alias name for the column header. If we left out this as and the alias name, then the column header would have just been whatever the calculation was. In our case, it would have said DOD minus DOB. So the alias is a nice way to make sure we have a more meaningful column header in our result set. The select statement calculations recognize all of these arithmetic operators. If you end up using more than one operator in a single calculation, be aware of the order. Just like we learned in elementary school, there's an order of precedence. The third column here shows the precedence from left to right as the calculation is processed. So for example, multiplication, division, and modulus would be done first from left to right, and then addition and subtraction. Functions can also be a part of the select clause. Here is an example of a function called concat that takes groups of strings, and in this case a calculation, and joins them together. There are many different types of functions, and we'll learn about these functions in a different lesson. But the point here is that functions can be used in the select statement. If you end up having a query with a result set that has repeated values, you can use the distinct keyword to eliminate the duplicate rows included in the result set. Here's a query getting all of the countries of the artists and if they're local or not. We can see that some of the result set rows are duplicates. Here is a query, the same query with a keyword distinct after the select keyword. Now you see the distinct prevents duplicate rows from being included in the result set. The where clause will filter the rows from the result set according to the conditions that you give. This enables you to see just the rows that you need. Comparison operators are used in the where clause. Comparison operators do just what they say. They help you compare one value or string to another. Are they equal? Is one bigger or comes later in the alphabet or smaller? Or are they not equal to each other? Then, according to the results of the conditions, only those rows in the result set will show up. Let's take a look at these comparison operators in action. In this first example, using the equal sign, the where clause reads where country is equal to Italy. So only the artist's first and last name will show up if the country is equal to Italy. Italy is another attribute in each row of the artist table. Even though we don't show the column in the select statement, we can still filter using country. So Leonardo and Michelangelo are both from Italy. Let's look at the greater than and less than sign. In the example on the left, the where clause states where DOB or date of birth is greater than 1606. So only the artist will show up if their date of birth is greater than or after the year 1606. The example on the right adds the equal sign to the greater than sign. Now you can see all the artists whose date of birth is after or on the year 1606. So Rembrandt, who was born in 1606, now shows up as well. Before, it was only those born after 1606. On the left here, if we use the less than sign, we're saying show everyone that was born before 1606. With the less than and equal sign on the right, we're saying show everyone that was born before or on 1606. So again, Rembrandt will show up. The less than and the greater than sign used together, or the exclamation and equal sign together, means not equal to. Our where clause here says where date of birth is not equal to 1606. So here we want everyone who was not born in 1606, which is everyone except Rembrandt, because he was born in 1606, so he does not show up. You can combine multiple operators in different ways to filter your results down even further. When you use the AND between two different conditions, both conditions have to be true for it to show up in the result set. So now the where clause states where country is equal to Italy and last name is equal to Da Vinci. Not only does the artist have to be from Italy, he also has to have the last name Da Vinci. Both those conditions have to be true. So and will filter down really narrowly to get just the results that match both conditions. Only Leonardo or only Da Vinci has the last name that matches and is from Italy, so he will be the only one in the result set. When you use or between the same two conditions or similar conditions, now either of the conditions can be true for it to show up in the result set. Everyone from Italy or those with the last name Picasso will show up. So now our filter is not as narrow. everyone from Italy and anyone with the last name Picasso will show up in the result set. You can also reverse or negate your condition with not. This will then show everyone who is not from Italy. There is also an order of precedence with and, or, and not as well. The nots will be evaluated first, then the ands, and then the ors. If you want to change the order that they're evaluated in, you would just use parentheses around those that you want to have done first, just like in math. There are even more operators that can be used with the where clause to filter down your results. In, between, like, and regular expression are some. With the in operators, a test expression is compared to a list of expressions in the in phrase. If the test expression is equal to one of the expressions in the list, the row will be part of the result set. Here we see that if country is equal to France or Italy, the row will show up in the result set. It's the same as if we had said where country is equal to Italy or country is equal to France in a compound operator. But the in phrase makes the syntax a little simpler. The between operator, when used in a where clause, will allow you to compare a test expression with a range of values. If the value falls within the range, the row will be included in the result set. Here are a few examples of how that might work. In the example on the left, if the date of birth lands in the range between the year 1500 to the year 1900, it will show up in the result set. The example on the right shows that you can also use it alphabetically. If the last name alphabetically lands between the letters H and the letter W, then it will be included. Something to note here with alphabetical ranges, if we had a name of Williams or Waters, they would also not be included because W is always less than WA and so on. So if you wanted to include any name that started with W, you'd have to put the range between H and X or H and WZ or something like that. The like operator matches specific simple string patterns to a test expression. In the first one, you're saying if the last name starts with Van and the percentage sign, it's saying that the Van can be followed by any number of characters after it. This matches two different last names. Van Gogh and Van Rijn show up. Another symbol that can be used with like is the underscore character. Instead of any number of characters like the percent sign, the underscore represents any single character. So the percent sign and the underscore characters are like wildcard characters that can represent anything. The percent sign being any number of characters, the underscore any single character. The regex or regular expression operator allows you to create much more complex string patterns to test expressions. There are many regular expression symbols that can be used. Here are just a few. The top left example is doing the same thing that the like example did, getting all the last names that begin with Van. The caret symbol this time represents the beginning of a string. The next one down gets all the first names that end in T. The $sign represents the end of a string. The last example is getting any first name that has an EN or an AN anywhere in it. So Vincent has an EN, Rembrandt has an AN, and so forth. There are lots of regular expression symbols, but we only want to introduce it here and let you know it's available, but not teach regular expressions in depth in this course. You can even find all nulls with is null, or all rows that don't have nulls with is not null. The example on the left is showing all rows that have a null for the middle name. The other is showing all the artists that do have a middle name. The middle name is not null or not empty. Okay, we're getting there. We have 2 more of the 5 clauses to go. There's lots of information here. Okay, the order by. Order by specifies the sort order for the rows in the result set. Most of the time, you use a column name to tell how you want it sorted. In this example, the results are alphabetized by last name. The default is to sort in ascending order. If you want to reverse the order to descending, you have to use the DESC keyword. This one shows the same query but with the keyword descending DESC added. Now the order is reversed. Those later in the alphabet show up first. You can even sort on multiple columns. This is sorted by country and then within country by date of birth. The limit clause specifies the maximum number of rows that will be returned. Even if there were hundreds of rows returned, if you said limit 5, then only the first 5 rows would be returned. Here on the left is a query run with all the rows that fit the criteria of the where. On the right, if we add limit 4 at the end, then only 4 rows would be returned. So again, you might have thousands of results, but you only need to see the top 10 or something like that. That is when limit would come in handy. So there we have the common clauses of getting data from a single table.